So this diagram is visible to all, the view 1, view 2, view 3.
Yes, sir.
Yeah. So this diagram is totally representing the our schema at the different level. So if we're talking about the each and every concept, so as we know, if this is our main database, this is our what? This is our main database where the information will be stored. But how this database is interpreted by the different level. So when talking about the physical level, so the level we can say at the physical level, I can write over here at the physical level. At the physical level, we have a schema that is known as the physical schema. If we're talking about the conceptual schema, so conceptual schema is coming from the logical level. So at the logical level, as we know, at the logical level, we have a schema that is known as the conceptual schema or logical schema. But in the case of the view, as we know, at the view level, we can have at the view level, we can have many views from the same database. So that's why we can say we have n number of views. So that's why in the view level we can have the many schema, and all these schema at the view level is known as the subschema. I can explain like this one by using all these level of the schema, we can say all individuals view 1, view 2 is known as a, we can say here, list of the subschema. For understanding purpose, I can write list of the subschema. So at what level we can say this is represented by the external level. So we have the external layout view and user, and this also layer is known as the conceptual layer based on the conceptual schema or logical schema. At the physical layer, we can say it is represented by the physical schema or physical layer. The physical level we have. So this is just representing of the entire information as we have discussed. Okay. Let me explain this concept in different way. So the picture or the idea will be clear to all in summarized way. Let me explain this concept in the detailed manner so the entire thing will be clear to all. So right now I'm taking a simple example, and I'm taking this simple example to you for benefit. Let me explain. First, I'm taking a simple example. What I'm taking, I'm putting the some details of the student. So students is what? Student is my name of the database. Student is the name of my database. I'm picking this one. From the student database, what are the its attribute or properties that are representing by the its structure? So the student structure can be represented by the student number, student name, student age, student date of birth could be, and its contact number of the students, we can say phone number, I can write over here, and that is enough, and we can write the class, in which class he or she has taken the admission. Let me clarify all the things properly so I can explain in detailed manner. This is some information I'm putting here. This is some information I'm putting over here in form of the our properties of students. These properties are known as the student number, student name, age, phone number, and class. For randomly, I'm just putting the two details only for understanding purpose only, nothing else specially. So what are those details? Student number, I have the 1, 2, 3, and 4, 5, 6. I'm just taking random data only. Student name is XYZ. Okay, PQR, just like this one only. Student age is 22 and 23 only, and phone number I am taking just 98262 something, and I am taking just randomly name number only. Just class, he has taken the admission in computer graphics, so GR for the short purpose, graphing, and cyber security. I am just writing short. Just nothing else, only the data. So at what level we have the data? So at the physical level, I can write over here at physical level. At physical level, the structure of the student, database will be managed. So what is the structure? The structure will be represented by the student number, student name, and age, and phone number, and the class. So these are the attributes, or I can say these are the various columns by which the structure of the physical schema we can maintain. So that is a physical. But when talking about the logical level, what we have, the conceptual, I can say that is a concept we have to understand properly. So at the logical level, what we have at the logical level, we are talking about the logical schema should be there. So what do you mean by the logical schema? Logical schema means the logical values. Basically, I can write over here the logical values of the database which is handled by conceptual schema. So I can write conceptual schema. Conceptual means what is the concept by which the information are put. So either logical level, the rows or records are maintained, to be maintained. That is a point you people are required to understand. Okay. First, tell me right now the logical level and physical level. We are discussing the physical schema and conceptual schema. Is clear to all right now? The phone number should be always integer, so I can put only the 1029 digit only. I can take the some integer data only. I can't put the phone number as a alphabet. So that is what constraint I'm using. So that is the logical or conceptual should be properly. So that is also maintained by the logical. Okay, right now these two parts are clear.
Yes, sir.
Yes, sir.
Okay.
So at physical level, like only the fields are being handled, and the at logical level, the records are being handled. Is it like that?
Yes, definitely. And we can say the physical level means we are talking about the storing the structure of the database on the disk. So what is the structure of data? What are the values which are managed by the this table or this database? And that is handled by the our logical level. Because what actually, see, you are writing a program. I'm talking about the simple concept programming language. You are writing a program. So you are writing the structure of the code, and that is stored onto the disk, that is to be maintained by the physical disk. But what is the logical behind the program? We have how this program is being manipulated and how it is treated for to representing the data and other information, and that is to be handled by the some logical concept. So at the programming, we have also have the different layers. First one is a physical layer, other one is a conceptual layer. Same is apart from the programming language, we have here two layers. Those are the physical layer, in which we have the physical level and which is maintained by the physical schema. And we have the logical level, or when you can say the conceptual layer, where the concept will be designed. So you just like the, you can't put the student name 756. Your name could not be 756. This could be the roll number, this could be the phone number, this could be the any digit, which is following by the proper meaning. So to apply the meaningful information, we have a logical level. So our work or our information in the historical disk will be divided to the various level. That was the point. Now clear?
So means at physical level, the data of the database is being stored in the disk, and at the logical level, we are just relating the data in the physical level with each other, so that so that it is from a row or a record.
Yes, of course. And see, that's why at the logical level we have a term metadata. If you remember the my words before system, metadata. So database is sometimes use the metadata. Metadata means data about data. So I can store the phone number into different parts. What is the country number, country code, and its area code I can take, and I can take the telephone number. When talking about the landline contact number. So definitely we can keep all the data. So all the data will be maintained by the logical unit. That is the point. Yes, you are on the right.
Okay, sir. Got it.
Got it. So at the view level, so from the same database, student database we have a student database. So from this student database, I need to just user A, who need to see the name of the student who belong to the age 22. Okay, so what is the condition I put it over here? The student age that is belong to the 22, I need to display only the such record only. So user A will get the some details, that is the 123 student number, student name is XYZ, student age is 22, and student phone number is 98262, and his class. So that is the point. The student who belong to the age 22, I am getting from the student database. Suddenly another student, another user, okay, or maybe student. So I can write as better idea. I can write user, another user who need to see the details of the student. So another user B, who need to see the student who belongs to the roll number 456. So student roll number who have the number 456. I need to see the age of the such student. So what is the detail I am getting? I am getting the student roll number and his age. So that is I am getting the age part. So what are the two fields I am getting? I am getting two details. One is a student number 456 and age, that is 23. So that is what from the user B and user A are both accessing the same database, but at the time we have a different view. So what we are getting at the first, I am getting the entire detail of the student who belong to the age 22, and next column I am getting the student roll number who have the roll number 456. So I am getting the his age and his roll number only. So I'm accessing the same database. So that is what from the same database you are having the different view. So that's why the at the view level we can have the many views. Third view where I need to display only the name of the student who belong to the roll number 123. So roll number and name I can display onto the my screen the student who belong to the name XYZ. So that is the way. So this is the our view level, and that is also known as the external view. So this external view will not change anything in the logical level or physical level. Whatever the information which is stored into this, we can access from the our database only. That is the thing. Now clear right now?
Yes, sir.
So that is the thing. All these things are not mentioned in the book. So that's why I am speaking once again. The please attend the class where we can discuss all the things. Same thing I am explained to the all the other students. So we have this example right. So that's why. Okay. So the point we have, sir, what do you mean by the service schema over here in our example? Yes, of course, in this example. See, by the help of the user A point, I am getting the some detailing from the schema. So that's why we can, this is known as the sub schema of the our sub schema of the other table. Sub schema means we are getting the all the details based on the condition. Okay, but in the user I am getting the two parts only, student number and age. So this could be also known as a subschema. So that is a point you people require to keep in mind that at the view level we have the many views of our information. So that is also known as a subschema. This is okay. So now this level is clear to all right now. What is mean by the physical level, logical level, physical schema, logical schema, and view level?
Yes.
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 Okay. So now should we move to the next point or any doubt over here? So you can ask and continue. No doubt?
No doubt, sir.
Okay. So it's time to look at the data independence. Without knowing or without understanding the physical level, logical level, physical schema, logical schema, and view level, or view schema, we can say, you are not able to understand data independence. We have some theoretical concept over here, so I will try to rectify the some concept step by step. Now, what is the data independence of the database management system? So this is the word we have to keep in mind. So what we have, you can easily note down over here. Data independence is defined as a property of the database and management system that helps you to change the database schema. And you can notify it over here. I have highlighted some terms properly over here, and that is the main important line. Now, what is its actual definition? Properties of a database management system that helps you to change the database schema at one level of a database system without requiring to change the schema at the next level. So here we have two types of the data independence. One is the physical data independence, other one is the logical data independence. For giving the simplification, I can give you some idea with the help of my example over here as we have discussed over here. Let me explain just idea about the physical schema, logical schema, as well as the physical data independence and logical independence over here. Now, this example is again is visible to all.
Yes, sir.
Okay.
Yes, sir.
Okay, this is a good point. Suppose I am just removing this phone number contact details. Suppose I am removing phone number. For a second, just keep in mind if I am removing this phone number. So student number, student name, age, and class, the column which are holding by the some values. Those are the 1, 2, 3, 4, 5, 6, X, Y, Z, PQR, and 22, 23, and gray in graphics and computer science or we can cyber security. So all these information will be removed or not? Tell me right now.
Yes, sir.
No, sir.
Now, one is saying no, one is saying yes. Just I need a proper answer. If I'm removing the phone number column for just due to just getting some detail only, there's no required to give the phone number. So remove this one. So other details which are holding by the its value will be removed or not?
No, sir. It won't be removed.
It will not
Yes.
be removed. Yeah, that's why we can say the data which are holding at the logical level, that is some logical value we are putting 1, 2, 3, 4, 5, 6 data elements we can say are not depend on the its physical structure. That is any column we can say. So if you are removing anything, so other information will not be deleted, will not be removed. So it means data independence, we have the any things which are depend on not depend on the any other level. So if whatever we are doing anything, whatever changes we are doing inside the logical level will not change at the physical level. Suppose a student told me, sir, no sir, this is my not number. So could you update my phone number? Yes, I'm updating his contact number. I'm updating his correct number 98364. Okay, rather than the 98262, I need to update his contact number 98364. So if I'm updating this information, then the phone number column, whatever heading we have, will not be changed. So it means that at the logical level, if I'm doing some amendment, I am doing updation something at the logical level. So the physical structure that is holding by the phone number contact phone numbers column name will not be deleted. That is the point you people are required to understand, and that is known as data independence. So the data which are holding by the physical level and logical level are independent from each other. That is the definition. This is summary. Now let us dive into the our important point. But before that, let me know right now this basic idea is clear to all right now.
Yes,
Yes,
sir.
sir.
So
Yes, sir.
okay. So now let me explain all these things properly. So what I have explained over here, the same thing I have written over here. Properties of the database management system that helps you to change the database schema at one level of the database system without requiring to change the schema at the next higher level or lower level, we can say. So at the physical level or physical layer or physical schema, we have a physical data independence, and we have also have the logical data independence at the logical level or conceptual schema, we can say. So level of the database, we have discussed what are the databases levels: external level, physical, conceptual level, and physical level. So the physical level and conceptual level, that is required to handle the physical data independence. Because with the help of the physical level, we are storing some information at the logical level, following by the logical schema. And of course, definitely at the view level, the different users are able to do some information. So that is the point we have to keep in mind. The level of the database schema we have discussed few minutes ago. So this diagram is no need to discuss more over here. Now, what is the exact definition? What is the exact definition of the physical data independence? So that is the point we have to keep in mind. Whatever we have discussed, I am just written over here. I am just giving the summarized. Physical data independence helps you to separate conceptual level from the internal or physical level. Yes, I 100% agree, because I know what is meant by the physical level and logical level, and I know what is the difference between the both levels. So what is its definition? Its definition is more clear and crisp here. It allows you to provide a logical description of the database without the need to specify the physical structure. So that is the point. The physical data independence is saying to us, without changing anything in the physical data structure, if we're changing something in the logical description, then our table will not be revoked, our table will not be, any amendment cannot be changed. Like this one. I can take one more example over here for a betterment. Just let me explain. Yeah. I was talking about my same example. I had student number. Next, I have the student name. Next, I have the age. Next, I have the phone number. And next, I have the class. So suddenly, I have forgotten to write the student address. Okay. So if I'm putting the, what I'm doing, I'm just adding one more field, that is address, to the my student database. So my all the logical description of the database, whatever I have, that will not be changed. So it allows you to provide the logical description of the database without need to specify physical structure. So if I'm trying to add something into the my table, or if I try to remove something from the my table, the information which is holding by the its phone number, contact number, and student number, and name, and age, and phone number, the class will not be changed. So I can add over here, but that is the point. If I'm adding or I'm removing something, so the rest of the part will not be changed. Rest of the column name, rest of the heading name will not be changed. That is known as the physical data independence. So physical data, the physical structure of the my database is totally different from the my logical structure, or we can say the logical layer. This simple meaning. Vice versa, we can say we have a term, this one. Yes, I've already explained, so that's why no need to discuss over here. So this is the next example I've explained to the other slot while discussing this point. So student schema I was talking. So what I did, roll number, student name, and age and gender I have. Previously, student schema I put it over here, only the student roll number, student name, and age. But I have forgotten to add the student genders. So if I try to put this data over here, so my other details, student roll number, and name, and age will not be changed. That is a point I have to keep in mind. So if I'm doing some amendment into the my logical structure, see at the last point. So see, like over here, in the student gender, I have forgotten to write over here correctly. So mistakenly, I have typed its gender, that is female, but it is student who is having the gender male. So that is what, if I'm doing some any amendment, if I'm doing something over here, so my this gender column will not be affected, and the name of the column name will not be changed. That will be as it is as gender. Or fortunately, I found this record is no more in my table because student has been better on the admission. Suppose that student has been better on the admission, so I did not need to continue with the students. So what I have to, if I try to remove such students detail from my relation of my table, my database, so all the columns which are holding by the values will not be changed. So without affecting any changes in my logical structure, what I have that is holding by the physical structure will be maintained. So that's why we have the logical data independence. So logical data independence is totally different from the physical data independence, but both are having the same sense. So any changes in the logical level you are doing, so physical structure will not be updated, and that is known as the logical data independence. Okay. And now at the physical data independence, if you're doing any amendment in the logical level, so physical structure will not be amendment. And vice versa, I can say if any change in the logical level you're doing, so physical structure will not be amendment, or any change in the physical structure you are doing, so logical values or logical information will not be amendment. And that is what that is known as our data independence. As the name suggests, data will be independent from from each other, or we can say data will be independent at different level. Now, this is the one end we have seen. Now, look at this point at the same level. At the logical level, you can see this is the record that is holding by the two roll number, and this is holding by the third roll number. So this record, and this record are this record and this record also independent from each other. Also independent. Now, why? Because you are removing the second row, then third record will not be removed. Third record will be as it is. If you are doing any changes in the third record, or maybe the age you are changing, just like the 22 to 20 you are updating, then the age of the third roll number will not be updated. The age which is mentioned, the 18 will be 18. So it will not be 19, it will not be 22. That is the point. So implicitly we can say the logic at the logical level, whatever changes you are want to do, you can do. So any no affection or no effective will be changed, or no effect will be there. Whatever we have entered, that we keep it as it is. So this is just idea about the logical data independence and physical data independence. Now it is clear to all right now. The fundamental part is clear to right now.
Sir,
Yes,
can
sir.
you see the example of the logical data independence again?
Yeah. So okay. So it is better idea I can take here once again over here. Let me draw all the things properly. So let me take one more example I am remembering right now. So okay. So I am taking an example of the product. Here's the product. Product is my name of the database, and in this product, I'm just keeping some information in product number and a product name and a product price. A random data I'm taking over here for a betterment, so the picture will be clear to all once again. So product number I'm taking the 123. Product name is XYZ, and price is 29.30 paisa, and again just 456. Okay, PQR. Okay, and this is 39.40, 39 rupees 40 paisa, and one more. And I'm taking the third value, that is 789 only, and I'm taking the ABC, and this is very low price. I'm taking the 11 rupees and 40 paisa once again. So this is our overall structure we have mentioned over here.
Yes, sir.
Okay, so now whatever changes, suppose I have forgotten to add here the company or brand name. Okay, so this is a company I'm taking. So I'm adding one more column over here. It means I'm changing the physical structure. Is it clear right now? I'm changing the physical structure.
Okay, sir.
So I'm changing the physical structure of my database, product database. So the information which is holding by the product number, product name, and price will not be changed. That will be as it is.
Yes, sir.
So I can write over here any changes at physical schema will not affect any logical value.
Yes, sir. This is
So
physical data.
So this is what this is the physical data independence. Physical data independence. Physically, data will be independent from the logical data independence. Clear?
Yes, sir.
Okay, so company name I am taking only the XYZ for just understanding purpose. Now, next I am choosing the different color for your betterment. So this one. Now suddenly I found over there this product number, product name we have mentioned over that is ABC. That should not be. It should be different like MN. So I'm changing something over here. So I'm changing something in the logical level. So at the logical level, we are changing something. Then it should not. I can write the comma for that word. It should not affect the physical structure. So P number, that is product number, product name will not be changed by any other name. So it will not affect the any structure of the physical structure. So I can write the physical structure. So this is what actually logical data independence. Logical data independence.
So, sir, at the logical level, we change the product name to the MNO, but at the physical level data, it remains ABC.
No. See, by changing means we are replacing this ABC product name by the MNO. So the picture P name, that is the product name, is our column which is holding the XYZ PQR ABC value. And if I changing some value in the ABC2 by the MNO, so the P name, that is the product name column, will not be changed. That will be as it is. The size, its data type, its nature will be as it is.
Okay, sir. Okay, sir. It means that data type and length, etc., will remain same.
Yes, of course. So there will be no change in its structure, which we are talking about.
But
There will be no change in
value
the
can
data.
be changed, sir.
Yeah, value can be changed. Value, if that value means
Okay.
which are managed by the logical level. So at the logical level, you are doing something by your code or your statement or your query. Then the P name, that the product name, is having its size and nature of the data will not be changed. That will be holding by as it is. So the effect will not be changed at any changes we are doing at the logical level.
Okay, sir. Thank you, sir.
So see, I can write over here for a betterment. Structure means we are talking about the data type and size, or you can say the length. That is good. Or I can put the arrow over here for betterment. Okay, now this clear. This is clear to all right now.
Yes, sir.
Okay, so this is just
Sir?
idea. Yes, tell me.
Sir, in logical data independence, sir, like if we change something at the logical level, then sir, its higher level would be external level.
So that's why that's why we have, if we are changing something like here I level with the external, I'm 100% agree right now. So you are changing the ABC to the by ML. So at the next level, if I need to see something, so whatever I will see, I will see the ABC or I will see the MNO. I will see the MNO. It means there will be no effectiveness, no dependency on my view. So previously I'm just put it a query. I need to see the product name which is representing by the product number 789. So previously, before updating anything, previously I am able to see the ABC product name. But the next time if I'm using to see by the help of this point, I'm updating something. So next time I'm just able to see what I will see. I will see the MN rather than the ABC because it was updated. So that is the point. The external level is and the logical level we have. So there will be no dependency. If you are having dependency, so it means our database will be not suitable. It is just like simple example. I can use simple way. While withdrawing the 10,000 rupees from the ATM card, so you have only 12,000 rupees, and now after withdrawing the 10,000 rupees, your account will be updated automatically. Account will be updated automatically, and after some time, you will check your balance. So what balance you will see? You will see only the 2,000 remaining, that is the remaining balance. So few seconds ago, before withdrawing, you have able to see the amount balance that was the 12,000. That is the one level view. You have seen the one level. Now next level you need to see after withdrawing, after applying the some operation on your balance. So you have been applied the logical level. So after applying the logical level, now your balance was reduced 12,000 minus to 10,000. We can say the remaining balance will be the 2,000. So 2000 was the your updated balances. Now next again you will check your balance, that is you are seeing the view. You are able to view. So now you are applying the view label, you are just able to see only 2000, that was updated. So that means the previous one or second one view was not dependent. So we can say logical level what we are changing, and whatever we are changing at the logical level will not change at the view level. View level just only the level which is used to view or data which are holding by the databases only. So main functionality will always be interpreted by the physical level and logical level. That is the point.
So, sir, in logical data independence, if we change a logical value, then the view will remain same.
No, view should not be remain changed. If you view remain will be changed 12,000 every time. So whatever the updation we have done, so it means view always showing the 12,000, 12,000. So the database will not be perfect. Previously it's shown many times, but now we are living in the 2021 era. So definitely it will not show the our previous information. It will show the updated information. So that is a point we have to keep in mind. Just let me show this point. See this point. So conceptual level or the logical level and external level, we have a mid part that is known as the logical data independence. So logical data independence will lies between the external level and conceptual level. So if you are moving from the conceptual level to the external level, then logical data independence will work perfectly. When talking about the conceptual level and physical level, so conceptual level and physical level, the mid point which is known as the physical data independence. So where respectively data independence lies, so you have to understand this contract.
So,
Just
so
now.
basically, physical data independence and logical data independence, they both work within the limits of conceptual level and physical level.
Yes, of course, because we are, see that's why no, that's why we can say the whatever we're changing at the physical level, it will not affect any changes at the logical level, but it lies between the both parts.
Okay.
Same thing we have over here, the conceptual level, we are doing any changes. So as external level, we will see the updated part. So definitely it lies between the external level and conceptual level. So that's why we have this diagram over here. Every time I have a sequence. So that's why we have to understand whatever the information we have. So that is the point. And store database, we have the huge number of data that we can have. So in our databases, we are not having the one database. In our databases, we are talking about the interrelated data. So we are talking about database management system. So it can have the many databases. So that's why here we have a 3 databases, for example. Okay, so now tell me right now. Yes, tell me right now, any problem? Is it clear to right now? So this is theory only. So I'm not going through theory, but I have explained this example as this product part and this for example. Okay, just tell me right now, any problem so far?
No, sir.
Okay, so after understanding these 2 points, let us understand what was the example of changes under the physical dependence. So we have this one right now. So modifying the file organization technique in the databases, that is changes we can say. So modify the file organization changes technique means we are transforming our structure into different format. So our database will not, the data which are holding by the our part will not be changes. So just like example, if I'm using the one model, okay, I'm using the one model of my database. I'm transforming my model to a different model, so the database, the information which is holding by the one model will not lose any information. If I'm losing some information, then what happened? My database is not having the data independence. That is the point. So B plus tree is a kind of the file organization technique we will see in the our fourth module. So that is the point. So modifying in the file organization structure I'm doing, so our information will not be changed. That is the point we have to keep in mind. It is just like simple example. I can say over here, just at your level, I can take simple example. Suppose you are writing a program. You are writing a program in .NET technique. And after writing the .NET the program, you are finally using the .NET based application, and you are storing the student detail at the backend side. Now everything is running perfectly, but in the coming days, after 2 or 3 years, a new technology was involved. So now new technology is invented in our society. So we are adopting such technology. Suppose I am using the Python right now. So after 2 years, I am observing the .NET based application, by which I am storing my database. I am storing my database into my disk. So what happened? Now I am adopting the Python programming language. So after adopting the Python programming language, so my database will not be accessible or not? Yes, of course, it should be accessible. Because with the help of my Python code or Python program, if I'm able to access my database, so I can say over here, the application which is designed by the .NET in Python are not, our database is not depend on the application tool. That could be Python, that could be .NET. So whatever technique I'm using for accessing my database, it doesn't mean to my database. So database is having the own sense, and an application program has the own sense. So I can integrate my database with any kind of the application program. So this is what is the dependency. It is not a dependency, it is independency. Same thing we have over here. If I'm creating my database into different structure, and I need to transform such a structure into the new technology based structure, so the stored information should not be changed. If it is changed, then what happens? I'm not following the data independence. So that is the beauty of the database management system. We have a data independence features. So that is a point. And switching the different data structure, means previously you are using a different data structure to create your file. Right now you are changing your data structure. So by the updated data structure you are using, so stored data you are able to access or not. If you are able to access, then there is a beauty of the database management system. But you are not able to access, then it means data independence feature is not working properly on your database management system. That is it. So different changes under the physical data independence we can have, switching the different data structure, modifying the file organization technique, and accessing the changing the access method. So changing the access method previously in the earlier days, when we were using the banking system is a computerized. We have the information sequentially. Now we have the index method. We have the random index method. We have a direct index method. So depend on the access method what we are using. So that is a point. And modifying indexing. Indexing means indexes is a aliasing of our databases that represent the data in the shorted way. The indexes means the aliasing we are using based on the shorted way. Previously, I was using the indexing based on the customer ID. From the beginning, I'm taking an example. Customer ID. But now customer ID is not a sufficient idea to sort all the customer name. So what I can do based on the customer's Aadhaar card number, I can sort all the record. So now if I'm modifying the indexes means aliasing of my table which is used to represent data in form of the shorted way, and that is known as the indexes. Indexes we will study in the practical, no issue will be there. So if I'm changing something, so my actual data which is storing by my table or database will not be affected, and that is example. Another example we have over here the compression technique to hashing algorithm, or changing the location of our stored databases from the C drive to D drive. So our database will not be lost. If it's so it means data independence we are not following properly. That is a point. And physical data independence we have, and logical data independence theoretically and with the help of the example I've already explained. But let me write now this example of the changes under the physical data independence. Any doubt over here?
No, sir.
Okay.
No, sir.
Okay, good. So logical data independence we have already discussed in detailed way. So same thing we have written over here. Any changes made will be absorbed by the mapping between the external and conceptual. And when we compare the physical data independence, it is challenging to achieve logical data independence. What are the examples we can see over here? Add, modify, delete new attributes or new information we are deleting. Suppose I'm just doing anything. I'm removing, I'm modifying, I'm deleting the new attribute. So I'm changing something. I'm removing the gender attribute or field, I can say. So the data which is holding by the other parts, which I will not be changed. If it is changing, then there will be no sense for that part. So at the logic level, what are the example we can changes? We can changes by some example here, removing any column, removing anything. So our information should not be lost. And if I found there are two records which are holding the same kind of information, so I can merge two records. Yes, of course, it is also possible. So if I try to merge two records with the linked list is the best example by which I can do. So with the help of the linked list, I will try to merge two records. I can do. If I'm doing, then what happens? Our information should not be lost, and that is a point we can understand. It is just an example of two students who are having the same father number or they are having the same address. It seems to us both are the brother and sister of each other. So we can combine the record of such a student into the merging pattern, we can say. Of course, that is also possible. So if I'm merging the both students record into my database, then what happens? Students should not be, other details should not be lost. If it is losing, then what happens? I am not following the the logical data independence. And breaking an existing record into two or more records, of course, is also possible. It is just example like this one. Yes. Suppose student contact number, roll number I have, student name I have, student contact number I have, okay, and student address. Now student class, student semester, okay, and student subject name. Okay, so these are the information I am having. Suppose I am dividing these entire student record into two parts or these records into two parts. If it's possible, then I can keep one information this way. So this is known as the student details. Suppose I'm giving, and with help of this part, I can say students record. Suppose this is the two tables I'm using. So I'm breaking my record or breaking my database into two parts. So the information which is holding by the previously database and previously record should not be lost. And if it is losing, then I'm not having the logical data independence. That is a meaning. So what I'm doing here, I'm breaking to let me write correctly, breaking into. Breaking database into two databases. So the stored information should not be lost. That is a simple meaning. So we have a logical data independence. So this is a simple example. Now it is clear all right now?
Yes, sir.
Yes.
Okay. Okay. So this is the example. So architecture of the database memory system is very interesting point over here. Okay. So before asking anything, moving to the next point or any topic, so if you have any doubts, so please you can ask me right now. Okay, no doubt.
No, sir.
Okay, so here I have some terms over here. After understanding the sequentially each and everything, what is mean by the data, databases, and its label and schema and its data independence feature and other part with the help of the examples. So architecture of database management system is again more important point. Now let us understand why. I will explain two types of the architecture. That is the point you people required to keep in mind properly because in the examination, most of the people will do the mistakes. To avoid the mistakes, I have categorized my database architecture in two parts. One is representing by the data base system architecture in tier based architecture. And next example I can take over here, database system architecture. System architecture will be the bookish architecture. Database system architecture is totally a bookish architecture. Okay, so I'm using the Hampton Codes database system architecture, and which is standard and most important architecture to explain the database management system. But in the case of the architecture of the database by the help of the two-tier or three-tier architecture, that is a tier architecture, so we have the three different. But what we have over here, so database system architecture has development, implementation, design, and maintenance of a database and store the organized information for agencies, business, and institutions. So in this base of the any database system which allow to perform the function effective and efficient. That is the term. So why we are understanding database architecture to identify the functionality of the any organization with smoothness and by the effective and efficiently. So enter concept we have over here that is put in by the properly. So without wasting much time, our system architecture, we can say our system architecture. So I will not say this is system architecture. This is the architecture of database system based on the time. So I can write over here for betterment in new future you will not do any mistakes. So this is database, we can say right data DBMS architecture based on we can say time. So we can say this is known as tier architecture. This is known as a tier architecture. So please keep in mind in the examination, if I ask actual tier architecture, then you people are required to write this one. Okay, so you have to explain one tier, two tier, three tier architecture. But in the examination, if I'm asking the system architecture, then you have to explain the system architecture. That is a different. You have to keep in mind properly. Okay, so with these words, let us start this architecture of a database management system. So first one we have the one tier architecture, and next we have the two tier, and next we have the three tier architecture. So this is a one tier, two tier, and three tier, and here we have. I think just first let me know right now. Any doubts so far you have or not? Just tell me right now. Any doubts so far?
No, sir.
Okay.